Right now, we're living through two of the biggest transformations in human history, and they're happening at the exact same time. But what happens if they're pulling us in completely opposite directions? Let's unpack this incredible conflict between our digital future and our planet's survival.
Okay, so on one hand, you've got the digital transition. This is the AI revolution. It's a huge technological leap that's set to remake our entire society. But it has a secret. It runs on an immense, and I mean immense, amount of computational power. Then, on the other hand, we have the green transition. This is our urgent global race to decarbonize everything, to switch to clean energy and fight climate change. Both of these are absolutely non-negotiable for our future.
And that really brings us to the core question here. Are these two essential goals on a collision course? Is the very tool we're building to create a smarter world actually going to sabotage our efforts to build a sustainable one? To really get a handle on this clash, we first have to look at the problem. And that is AI's absolutely voracious appetite for energy and resources. The scale of this is just staggering, and as you're about to see, it's growing at a rate that is, frankly, kind of alarming.
This one number really makes it all concrete. A single question you ask a tool like ChatGPT can use 10 times more electricity than a classic Google search. Now, just try to imagine that scaled up by the billions and billions of queries happening every single day. You start to see how this demand just explodes.
And when you zoom out, the big picture gets even crazier. According to the International Energy Agency, the electricity demand from data centers is on track to more than double by 2030. It's actually growing faster than the demand from electric cars. This isn't just some tiny trend, it's a massive shift in how the world uses energy.
So, while data centers use about 1.5% of all electricity globally, their impact is really concentrated and intensely local. In the EU, it's about 3%, but look at a major tech hub like Ireland. That figure just skyrockets. Data centers there already gulp down over 20% of the entire country's electricity. That puts a crazy amount of strain on their grid and forces some really tough choices on their climate goals.
And, it's not just about electricity. These data centers are incredibly thirsty. We're talking an estimated 560 billion liters of water a year, mostly just to keep all those servers from overheating. This is a massive environmental cost that we don't often talk about, especially when these data centers are in places that are already short on water. But this is a paradox, right? It's not a one-sided story. So now let's do a full 180 and look at the promise. What if this super energy-hungry technology is also our best shot at solving the energy crisis itself?
This quote just nails the other side of the coin perfectly. The idea is that AI isn't just a problem we have to manage. It could be a powerful engine for optimization, something that could actually speed up the green transition and turn these two competing forces into companions.
So, how exactly would that work? Well, just imagine an AI that manages our power grids, making it easy to plug in renewables like wind and solar. Or an AI that finds and eliminates energy waste in our buildings. It's already being used to discover new materials for way better batteries. And when you add it all up, some analysts think AI could help us cut 5 to 10% of all global greenhouse gas emissions by 2030. That's huge. And hey, this isn't just some sci-fi theory. The results are already rolling in. Google used its own DeepMind AI to cut the energy it uses for cooling its data centers by 40%. Other AIs have sped up the process for finding the perfect spot for a wind farm by a factor of 4,000. So the potential is very real, and it's already being proven.
Okay, so we've seen the problem and we've seen the promise. Now it's time for a reality check, because the present is always way messier than the future looks on paper. We have to look at the gap between what all the big tech companies are pledging and what's actually happening on the ground.
On one side, you have these incredibly ambitious promises from the so-called hyperscalers, your Amazons, Googles, Microsofts. They're all promising to run on 100% renewable energy. But the reality is that the grid isn't 100% renewable 24/7. So they have to rely on this mix of buying green power directly and then buying carbon credits to offset the fossil fuels they're still using. It becomes this really complex accounting game that doesn't always reflect what's actually powering a server in any given moment.
To really understand this, you got to know about this key industry metric. It's called PUE, or Power Usage Effectiveness. It's actually pretty simple. It's just a ratio of the total energy a data center uses compared to the energy that actually makes it to the computer servers. A perfect score is 1.0. So the lower the number, the more efficient the data center is. It's basically the industry's report card for efficiency.
And because there is this gap between the pledges and reality, regulators are starting to step in. The European Union, for example, is laying out a really clear timeline for accountability.
In 2023, they started making companies report their energy and water use. This year, they're setting up a common rating system. By 2026, a new efficiency package is coming, all of it pushing toward this big goal of making all data centers climate neutral by 2030. The pressure is definitely building.
So, how do we reconcile all this? How do we get the digital and the green transitions to actually work together instead of fighting each other? Let's take a look at the path forward.
The solution isn't one single thing, it's not a silver bullet, it's more of a staged approach. In the short term, the hard reality is that this surge in demand is being met with more natural gas and by keeping old fossil fuel plants online longer. The midterm necessity? It's a massive, massive investment. We're talking hundreds of billions of dollars every single year just to upgrade our power grids to handle this new demand. And the long-term vision? Well, that involves completely reinventing the computer itself.
This long-term vision is centered on some really cool ideas, like neuromorphic computing. This is a total redesign of computer hardware, inspired by the human brain. Instead of keeping memory and processing separate, it integrates them. The whole goal is to create computers that can learn and think using just a tiny fraction of the power and data that today's AI needs. It's about solving the energy problem at its absolute root. But until that futuristic tech is ready, our energy future is going to be, well, complicated. Just look at this forecast. Even as renewables grow, data centers will keep relying heavily on natural gas to get that stable, 24/7 power they need. And notice that growing slice for nuclear power. A lot of people see nuclear as essential for providing that round-the-clock, carbon-free energy. There's just no simple, easy switch.
And that brings us right back to our final massive question. AI is here. It is reshaping our world faster than we can probably comprehend. The challenge for all of us, for the tech world, for our politicians, for us as citizens, is to steer this incredibly powerful force. Can we make sure that artificial intelligence powers the sustainable future we desperately need instead of becoming the one thing that delays it? The answer to that question is going to define the next 100 years.